Welcome to your geometry week of August 30th assignments. Hard to believe that we are about to enter into September. At this time, I do want to make sure that you've got your math notebook out. Remember, you should have a math notebook. I do require you guys have a math notebook, and you do need to be taking notes as you're going through your lessons, as well as you're watching this recording. These notes will help you when you come to do your graded assignments for the week. The first thing I'd like you to use your math notebook for is this warm-up problem. So we are going to take a moment to review what we did last week, where we looked at the segment addition postulate in Unit 1, Session 2. This will be a great review for you because you will be taking your first quiz this week. And I'll talk about that in just a moment. So I would like for you to grab your math notebook, and in your math notebook, I would like you to complete this problem below. So the problem is right here, and you will be using the segment addition postulate as well as the midpoint of a segment postulate. So what is the problem? It says point D is the midpoint of segment CE. So remember, when we write points, we use capital letters and just one letter. And when we talk about segments, we use 2 points and as well as capital letters too. So point D is the midpoint of segment CE. So think back to what a midpoint is and how it breaks up a segment. And then here's some information. If segment CD is equal to 2x and segment DE is equal to 4x minus 6, I want you to set up an equation where you can solve for x and then find the length of CD. So I would like you to draw a picture to help you solve this. And again, to solve this, you need to think about what a midpoint is and how it breaks up the segments. So if you need to look back from your notes from last week, go ahead and do that. But I would like you to click pause and to work on this problem on your own. And when you're ready to check your work with mine, go ahead and click play. Alrighty, remember you do need to be trying these problems on your own first and then check your work with mine. You'll get so much more out of this if you actually try it on your own in your math notebook and then check your work with mine. So what is a midpoint? So we were told that D is the midpoint. So remember, a midpoint divides a segment into 2 equal parts. So that's what a midpoint is. It divides a segment into 2 equal parts. So we know then, because D is the midpoint, we then know that segment DC or CD would have to be equal to segment DE because we were told that D is the midpoint. So then we were also told the length of our segments, that CD is 2x and from D to E is 4x minus 6. Well, we can set up an equation now, can't we? Again, since we were told that D is the midpoint, we know that CD is equal to DE. So now I'm just going to substitute in the values that were given. CD is 2x and DE is 4x minus 6. So I can state that those 2x and 4x minus 6 are equal because of the fact that D was the midpoint. And now all we're going to do is solve for x. So I'm going to work on getting x all on the left side of the equation. So I'm going to subtract 4x from both sides. 2x minus 4x is negative 2x equals negative 6. I'm going to rewrite this up here so that we've got some space to work with. We need to solve for x, so I'm going to divide each side by negative 2. And I get my value of x. X equals negative 6 divided by negative 2 is a positive 3. So I found the value of x. I would also ask you guys to find the value, or the length, that should say, the length, not the value, the length of CD. Well, remember, CD was equal to 2x. So all I'm going to do is substitute in that value of x equals 3. So whenever I see the x, I'll plug in 3, and I'll find the length of CD. So CD equals 2 times 3, which is 6. If CD equals 6, what would the length of DE equal? It would also have to equal 6 because we were given that D is the midpoint, and we know that D divides, or a midpoint divides a segment into 2 equal parts. So the length of the segments would have to be the same. Alrighty, so that was a great review of what we did in Unit 1, Session 2. Which is nice because, as I mentioned, this week you guys will take a quiz over sessions 1 through 3. Before you take the quiz, you will be learning about angles and, oops, that should say not the segment addition, the angle addition postulate, which is very similar to the segment addition postulate, but now you'll be using angles. So before you take the quiz, you will complete Unit 1, Session 3 this week, learning about angles, types of angles, and the angle addition postulate, and then you'll move on to take the Unit 1 quiz covering sessions 1 through 3. So just some reminders as you're working this week. Make sure you're checking your grades. I will be grading all of week 2 assignments. If they're not already graded by the time you watch this, they will be graded shortly. So make sure that you're checking your grades. Go into the grades tab, click on the actual assignment to open it up and see what you missed. Don't just look at your overall grade. You need to dig in deeper to see what is it you missed specifically, and read my feedback. And this will be great review as you're preparing for the Unit 1 quiz, is to take time to go through and see what you missed. Remember, you can retake low-scoring assignments. And that, again, is a wonderful way to review for the quiz, is to redo low-scoring assignments in sessions 1 through 3 as you prepare for the quiz. Remember, if you redo an assignment, you must message me, otherwise I won't know to grade it. So just send me a quick email. And then I already talked about this. Make sure you're taking notes as you go through this recording and your lessons this week in Schoology. You do need to be taking notes in your math notebook. All right, so I did want to quickly review some things from sessions 1 through 3. First of all, how we could tell the pre-image from the image. I saw there was a few of you who still weren't quite sure how we differentiate the pre-image from the image. Remember, the pre-image is the figure we start with, and the image is what we end with after we do some kind of transformation. And you'll notice that I have 2 images here, and you'll notice that the letters are the same. So we've got point A, and we've got point A over here. But if you look really closely, over here we've got a little tick next to the A, or an apostrophe. A prime is what we call it in math, a prime. Right here we've got B, and then this B has an apostrophe, which again, that's called the prime. So what does that prime tell us that's next to all the letters of this blue image? That tells us that this is the image. This is the image. This is the after some kind, make that up. This is after our transformation has taken place. So when you've got your primes next to the point, the primes let you know that this is the image. It's after some kind of transformation has taken place. And you'll notice the pre-image in the red does not have the primes next to it. So that's how we tell the difference. Alrighty, translation mapping, just a quick review of what else we did in Unit 1, Session 1 was we looked at translation mapping. And translation mapping tells us what direction vertically and horizontally a image has been moved for translations. So translation. So if we have this translation mapping, what directions did the figure move? And remember, over is not a direction. Over is not a direction. You need to use left or right. All right, so the x plus 4, anything that's associated with the x is talking about horizontal movement. And since we have a plus, that means the figure moved 4 units to the right. We wouldn't say over, we would say to the right. What about that y minus 5? What does that tell us? It tells us that we're going to move down, so we would go 5 units down. So that is what this annotation would tell us, and that's just review from Unit 1, Session 1. You will see stuff like this on the quiz. I'm going to go on to the next slide, so if you need more time, go ahead and click pause. Angle addition postulate. So we already reviewed the segment addition postulate, but let's move on to Unit 1, Session 3, which is all about angle addition postulate. I'm going to hit on this very quickly because I don't want to make this recording too long, and there's plenty of lessons and the slides in Unit 1, Session 3 where you're going to learn all about this. But the angle addition postulate is just like this segment addition postulate. So let me go ahead and draw an angle in here. So I'm going to draw, actually, if we look, it's actually a couple of angles. And let's talk about how we name angles first. So we name angles by using the points on the angles. So I'm going to call this A, we'll call this N, we'll call this S, and this T. So a couple different angles here. So let's just focus on this angle right here that I'm highlighting in yellow. So we would call this angle, I put a little angle in front of it, and then I would call it angle ANS, or we could call it angle SNA. What's important is that when we name an angle, the vertex, which is this point that connects the two arms of our angle, the vertex is always in the middle. So if you'll notice, our vertex is N. The vertex always has to be in the middle of the two other points when we name our angles. So you'll see that this week, that when you're looking through Unit 1, Session 3, that the vertex is always in the middle of your two other points when you're naming your angles. And then you can see that we've got another angle here. We've got this angle with this leg and this leg of our angle. What would we call this angle? What could we call that angle? What are some names? If you said angle SNT, you are correct. How could we name that same angle using a different order of our points? TNS. Could we call that angle in red? Could we call it STN? No, because remember, the vertex has to be in the middle of the other 2 points. And we actually have a third angle here, if we look at it in terms of the bigger angle. So if we look at it in terms of this entire angle like that, we've got a third angle in here. And that would be angle ANT or angle TNA. It doesn't matter which order you want to use it in. It doesn't matter as long as the N, the vertex, is in the middle. All right, so I'm going to erase the naming here, and let's talk about the angle addition postulate. So if I were to label these smaller angles in here, and you'll see what I mean in just a second. So we label angles by putting a little arc. You can see I added a little arc for angle ANS. I added an arc in there. And I'm going to say that that angle is 40 degrees. And then I'm going to label angle SNT as 30 degrees. So what I've said is that the measurement of angle ANS, and notice to write the measurement, I just put little m or lowercase m, angle ANS. So the measurement of angle ANS is equal to 40 degrees. The measurement of angle SNT is equal to 30 degrees. Can you now figure out what the measurement of the big angle, that ANT, that angle would be? Well, think of what we did for the segment addition postulate. So if we were just to say that the measurement of angle ANS, if we add that with the measurement of angle SNT, we'll get the measurement of that big angle here, the ANT, that makes up this entire angle, which would be measurement of angle ANT. So that is what this segment addition postulate is if you add up the two smaller angles, you'll get the measurement of that big angle that is made up by the two smaller angles. So if we know that the measurement of ANS is 40 degrees, I'm just going to substitute in that all of this information. So we know ANS, that measurement is 40 degrees. We know the other smaller angle, that SNT, is 30 degrees. So if we add those up, we would get 70 degrees. So the measurement of that larger angle ANT would be equal to 70 degrees. So again, what I did was I added up the two smaller angles, and that's going to equal the length of, the measurement of that bigger angle ANT. So that is the segment addition postulate, and you're going to get practice with it this week and using the segment addition postulate. You're going to also get angle, or not necessarily have angle measurements. You might be given equations just like with the segment addition postulate of like 2x and 3x minus 6, where you're just going to set up equations like this and solve for unknowns. All right, I'm going to move on. So if you need more time here, go ahead and click pause, but I'm going to move on to the next slide. Just a friendly reminder that you're taking notes this week, so you're going to learn a lot about different types of angle pairs, like complementary, supplementary, vertical angles, linear angles. Make sure that you're taking notes, and I suggest that you draw pictures as you're taking the notes and defining the different vocab this week. So that will help so much for you guys if you're taking notes and drawing pictures as well. And that's it. So we are done. And remember, you do get 10 points for watching the recording. And the way you do that is by completing the key phrase assignment. So I'm going to put up a question in just a moment, but just a reminder of how you complete the key phrase assignment. So first, make sure you're logged on to your geometry class. So go on and log on to Schoology and go into geometry. Then click on the materials tab. And then when you see the weekly recordings and key phrase assignment folder, click on that. And then look for the week of August 30th. Remember, the key phrase assignment needs to have the same date as the recording date. So we need to look for that week of, since this is August 30th, that's what the date of your key phrase assignment needs to be. And then let me put up the key phrase assignment that you're going to answer. All right, so here's the key phrase assignment. How can you tell the pre-image from the image? So we talked about transformations in Unit 1, Session 1. And when a transformation takes place, we go from the pre-image to the image. And we talked about the special notation that's used so that we can tell which is the figure we start with and which is the figure we end with, and then we can figure out what kind of transformation has taken place. But there's a special notation that I've talked about twice now in the recordings, and it is in your lessons as well. We talked about it today in the recording. So what is that special notation that lets you differentiate the pre-image from the image? So that's all you need to tell me, and make sure you click submit, and then you're done. So have a wonderful rest of the week, and let me know if you have any questions as you're working this week.